Today we're talking about Pythagorean Theorem, or PT for short. There's basically two uses for Pythagorean Theorem. Number one is the most common. You're going to use it to find the third unknown side in a right triangle, but this is very important. You can only use number one if it's a right triangle, okay? Number two is a little less common, but you can also use Pythagorean Theorem to determine what kind of triangle you have. If they give you three sides, you can determine if it's acute, obtuse, or right. I'm going to start off with number one. Okay, so you want to draw a right triangle, and this is the equation for PT, a squared plus b squared equals c squared. It's extremely important you understand that the c is the hypotenuse. Hypotenuse means the longest side of a triangle, in this case opposite the 90. The side opposite the 90 has got to be the hypotenuse, that's got to be c, that's got to be the hypotenuse. These two are the legs, the two legs touch the right angle, leg, leg, right? Make sure you remember that. Do not put the hypotenuse over here and don't put a leg over here. It's a very common mistake. Don't do it. Okay? So let's do an example. So what if I told you that A is 3 and B is 4? First thing you want to do is you recognize that it's a right triangle, and then write this equation down immediately. Then plug it in. You want to write this down because it's going to give you a roadmap of what to do, and you're less likely to make mistakes. So A3 goes here, 3 squared plus 4 squared equals c squared, right? So 9 plus 16 equals c squared, 25 equals c squared, c equals 5, so the hypotenuse we just figured out is 5. This is a 3, 4, 5 triangle. This also happens to be a special triple, but that's for another lesson. So there you go. We just found the third side in a right triangle. But that was pretty easy because they gave you the two legs. You're looking for the hypotenuse. What if they changed it and they gave you the hypotenuse and the leg, but not one of the other legs, right? Okay, so to keep this simple, I'm going to use basically the same numbers, but here we are given the hypotenuse, and we're given one of the legs, but now the other leg is unknown. Remember, this is the hypotenuse, okay? So, again, write down the equation. And then, this is the unknown, so we just leave that a squared plus 4 squared equals 5 squared, a squared plus 16 equals 25, a squared equals 9, a equals 3. So if we know the hypotenuse is 5, one of the legs is 4, then we automatically know the other leg must be 3. So you can use this equation whether they give you the two legs or if they give you one of the legs and the hypotenuse, but you got to put them in the right place. These are the legs and this is the hypotenuse. Okay? So that's basically number one. But remember, you can only use number one if it's a right triangle. Okay, so what about number two? So hopefully you understand what acute, obtuse mean, and right, of course, is 90 degrees, right? But acute means less than 90, and obtuse means more than 90, right? So you can use this equation to test what kind of triangle you have, not necessarily knowing if it's a right triangle or not, right? So for number two, the problem would have to give you the three sides, right? So let's say they gave you this three sides, 3, 4, and 5. Okay, you probably already know that's a right triangle, but let's pretend that you didn't, right? So obviously, which one's the hypotenuse? The longest side is, so 5 is the biggest side, so we plug the 5 into C, right? So we do 3 squared plus 4 squared equals 5 squared, right? And so are we going to get a true statement? 9 plus 16 equals 25. Is that true? 25 equals 25. So if this is a true statement, then we know that this triangle right here is a right triangle. So if this statement is true for that triangle, then we know it's a right triangle. This is a true statement. We know this triangle here with these three sides is a right triangle, right? Okay, but what if that was not the case? So I'm going to change the sides. So what if we change the hypotenuse? So now it is 6 instead of 5, right? So now it's 3, 4, 6. However, which one's the hypotenuse? Okay, well now it's the 6, right? So we plug that into the equation. So we get, I'm going to write this down, a squared plus b squared equals c squared. So 3 squared plus 4 squared equals 6 squared, right? So 9 plus 16 equals 36. 25 equals 36. Well, is that a true statement? No, right? But basically, this does tell us something. Number one, it's not right, but it actually tells us something else. that is actually, let's see, when a squared plus b squared, when that is less than c squared, then we know it's obtuse. So because c squared here is bigger than a squared plus b squared, right? C squared here is bigger than a squared plus b squared, then we have this situation, and this situation here tells us this is an obtuse triangle, right? And that actually kind of makes sense because you saw that I increased the 6 from a 5, right? So the hypotenuse got a little longer, right? So when I make the hypotenuse longer, I have to turn the legs away from each other, and when they move away from each other, the hypotenuse gets larger, but when I spread the two legs, then the angle gets bigger than 90, which is what? An obtuse angle. So this statement here totally makes sense. So when the hypotenuse squared is bigger than the sum of the two legs squared, you know it's going to be obtuse, right? So then you can probably guess what's going to happen if I change that third side and I make it something less than 5, right? So let's make that third side 4. Now in this case, I guess technically there's no hypotenuse because we have two sides but that are the same. But we can still do the same thing. So we can basically say 3 squared plus 4 squared equals 4 squared. 9 plus 16 equals, what is it, 16? 25 is obviously not equal to 16. So number 1 is not a right triangle because this is not a true statement. And then number 2, when a squared plus b squared is greater than c squared, then we know it's an acute triangle. Acute meaning the angle is less than 90, which actually means all the angles are actually going to be acute. But again, if we take these two legs and I decrease this right angle, what happens to the hypotenuse? The hypotenuse gets smaller, which means the two legs, when we square them and add them together, should be larger than that hypotenuse, right? So if I increase the angle, right, then the hypotenuse gets bigger, and then we know this angle gets bigger, so this is an obtuse triangle. But if I decrease that angle, the right angle, it becomes acute, which means what? The hypotenuse gets smaller, and so therefore the sum of the squares of the two legs is going to be greater than the hypotenuse because the hypotenuse got smaller, right? So if you think about these things, it makes sense. That's how you do number 2. Yes, so hopefully you understood that. If you did, good job. If that was helpful, please like my video and subscribe to my channel. And let me know in the comments which topics you guys want me to do next. Thanks for watching.